I'm not quite sure that what kind of audience you have. So my assumption is most of you may be university students. And so when I thought about, talking about these different pathways of astrophysics, so there are two sections that I have to talk. So the one is the different areas that we can talk when we talk about the astrophysics, and also then different career paths that you could have by studying astrophysics, right? So I will first go to different areas that we used to study or that we used to divide when you study, especially different research areas in astrophysics. And then I will move on to, just give you a kind of, overseeing or a kind of a picture about different career paths that you could have in astrophysics, because this is one of the questions that most of the time I get. And in fact, as far as I remember, I did the same kind of topic before, I guess, for one of the SEDS talks that probably I have given a few years ago. And so if maybe some of you were there, you may remember that. So I'm kind of using most of at least some of the slides that I used there as well. And to start with, let me start in this way. So when you search about different areas in astrophysics, so let's say you Google it or you just type it in the chat GPT, you get a lot of different topics. But with my experience, I just divided this into several different sections. But just keep in mind that this is like not any textbook type, topics. So this is just what I thought. Maybe someone else can, come with slightly different research areas, which are kind of maybe include these. So you can, divide again into different subtopics, these areas as well. But in general, let's say you need to study, you kind of are passionate about astrophysics and you are excited to, do research or learn something about the astrophysics. Most of the time, you may be working in planetary science. So that means study about the planets, especially in our solar system. And maybe you will be learning about exoplanets. Exoplanet means the search for planets outside our solar system. So that's a different research area. And then next thing that usually comes into my mind is the stellar astrophysics. That means the studying about the stars. And once you go a little bit beyond that, then you will have galactic and extragalactic astrophysics. So that means you are kind of learning about the galaxy. For example, our own galaxy is the Milky Way. So you start learning about the galaxy as a one unit, and then other galaxies beyond our galaxy, right? So this is called extragalactic astrophysics. So that's a different research area, right? And then if you start learning about the universe as a whole, like the beginning of the universe, the evolution of the universe, those kind of things, so that belongs to the cosmology, right? And so if I come back again to our solar system, the sun is very special for us, and therefore there are a lot of research going about the sun. So there is a separate section called solar physics that you apply physics knowledge to study about the sun. And then the gravitational astrophysics is another research area that is about, all these the objects that you have in the space. The main driving force to connect force that connects each other is gravity. So there are other forces available, but gravity is kind of the master force that you always used to talk. And in addition to that, you probably have heard about these gravitational waves that came into came into play after 2016 or so, where the scientists have very first observations of the gravitational waves coming from the space, which are usually happens due to the merging of black holes or the black hole and neutron stars, those kind of things. Now, the interesting thing about the gravitational waves is uh, usually for all these research areas, when you need to observe something, let's say for a star, for a planet, anything that you observe, you have to do the observation through our electromagnetic spectrum. And all of you, if you have done some kind of science, all of you know about the electromagnetic spectrum, right? So you have the gamma rays, X-rays, and the visible light, and then ultraviolet, those kind of, the spectrum. And this gravitational wave is a completely different thing, which is predicted by Einstein from his general theory of relativity. And we have been known for a long time that theoretically it should be there, but nobody has observed it until, let's say, 7 years ago. So it's around 2015, 2016 time when I was doing my PhD. And the first time these gravitational waves were detected. And this opens a completely new area of new research area. Now, under this gravitational astrophysics, you do a lot of gravitational interactions, like the research in gravitational interaction, and also especially the gravitational waves. Gravitational wave astronomy plays a big part in this gravitational astrophysics now. And apart from all these different research areas, one of the very interesting research areas is instrumentation and observational astrophysics. And there are two things here. The instrumentation is making these instruments. For example, the Hubble Space Telescope, James Webb Space Telescope, and all the other, ground-based telescopes and the cameras that they use. So all these goes under the instrumentation, right? So you make instruments that you have to use for the observations, right? And then observational astrophysics again is a separate, it always connect all the other fields. So you do observations, right? So instruments and the observational astrophysics in that way are two different research areas. Once again, just keep in mind that even though I divide it in this way, it's not a theoretical division that you cannot, sometimes, separate each other by a hard line. So you cannot do that. And so I have a small video clip here just to show you how these different, research areas work. And when you are working in certain areas, what kind of scale that we are looking at, right? Now, let me play this video. And as the starting point, what you see here is you can see on this right-hand corner, this is our own, our Earth right here. So if I start playing this video, this is our solar system right here. So this is, so when you start, studying about the astronomy, this is the first thing that you are going to study, right? So you have the sun at the center, and then all of these, the planets going around it, right? So I think everyone knows about it. And the areas that I talked to you, the planetary science and the solar physics is especially dealing with this scale, right? So inside our solar system, planets and the sun, right? And then if you move a little bit forward, then you have our galaxy. And you can see that right here, there is a small one of this. Our own solar system is located in one of the small location in one of these spiral arms in our Milky Way galaxy, right? So if you are studying the solar system or the planets inside the solar system or our sun, so that means you are just studying only this area right here, right? So you are not focusing anything else. So you just study that particular area, right? And so if you go into the next level, which means studying about the stars. So, you know, there are a huge number of stars available. And so if you are going to study the solar galaxy, there are billions of trillions of stars available. So if you are going to study those stars, so study means we basically looking at, you know, the stars, they have a very nice life story, right? So there is a mechanism that how you can give birth to a star. If there's certain conditions occur, then you have, you know, the stars. So they especially have these mechanisms that you can give birth to the stars, and they continue their lifetime, and they are evolving into different, you know, stages. Now, these different words that you usually hear, white dwarfs, neutron stars, black holes, then red giant stars, all these different names that you used to hear in the news are actually different stages of the evolution of these stars, right? So so the stellar astrophysics is a big part. There are a lot of research going on that section, and there are separate devoted missions that study stars. For example, there is a mission called Gaia mission, which specifically sent to the space to measure the distances to each and every star, not all the stars, but you know, billions of stars that you have inside the Milky Way. You measure the distances from that mission, and you take those data and do the research, right? So those kind of research especially goes to the stellar astrophysics section, and also exoplanets. Exoplanets means planets outside our solar system. So when we say exoplanets, we are specifically looking at the exoplanets inside our galaxy, but outside our solar system. There are actual instances now after 2020 and 2021 time that you also look at the exoplanets in the other galaxies as well. But mostly we used to look at our own galaxy. So if you are looking at, you know, the research areas like stellar astrophysics and exoplanets, basically you are looking at this particular area. And if you go into the next section, which means you can see what is there when you go outside our Milky Way, right? So you can see that in the next picture, the Milky Way is right here, and you have other galaxies visible now, right? Now you can see that when you go for these different research areas, we are looking at different scales of the universe, right? Now, when we look at other galaxies, so this is where we study, where the studies focus on this extragalactic astrophysics. As the name suggests, what you are looking at is galaxies outside our galaxy, right? So you can see that when you focus on this particular research area like extragalactic astrophysics, which means you are looking at the other galaxies, you don't even think about this scale right here. Because if you think about our own solar system, when you are studying about the extragalactic astrophysics, which means you are looking at the properties of these individual galaxies outside our main galaxy, which is Milky Way. So our solar system is actually located, if you get this picture, inside this picture, you have our own Milky Way, which is a small entity with respect to the other galaxies. And inside that Milky Way, inside a small spiral arm, that you have the solar system. So you are not bothered about, you know, studying these kind of systems when you go into this scale, right? So that's what we call as the extragalactic astrophysics. And then when you continue, so you go into the other scales, which means when you add up all these galaxies together, we make clusters. So we basically used to tell the word galaxy clusters, which means collections of galaxies, right? So they come as a unit. So that is also usually we call it as extragalactic astronomy, but it's a different entity that you have, thousands of galaxies collected together, and we call those as galaxy cluster. So you're basically looking at galaxies, right? And then if you go into the more higher scale, you are looking at the universe as a whole. And when you go into that scale, we usually study about the beginning and the evolution of the universe, which we call as the cosmology, right? So I hope this picture particularly provide you an idea about, different research areas that I talked in the previous slide right here, and how they related into different scales, right? So once again, don't think that I have, covered all the research areas. So depending on the limited time I have, I just introduce you few research areas that you may be studying in future if you selected or interested about astrophysics, right? So that is one thing that I would like to talk with you. And then the next thing is, now to study research areas, what you should do, right? So assuming that you are interested in studying astrophysics, and then now you know what kind of research areas or different areas that you can study. And then the next question that you should have is what you should do in order to study these research areas, right? What kind of education that you should have, where you should go, and what will be the qualifications that you should have, those kind of things. And of course, you know that in Sri Lanka, it's very limited that you have the opportunities to go for, do these research areas. And one thing that you need to understand is there are two kind of, when you study about astronomy, there is a certain section called amateur astronomy. So that means you do astronomy as a hobby. So you have a small telescope, and maybe you use DSLR cameras and make pictures. And this is kind of doing astronomy as a hobby. And it is also a big part now in the world. But what I have my focus is here is not about the amateur astronomy. So this is called professional astronomy and astrophysics. We are what professional astronomers do. So my talk is mainly focused on that side, right? Right. So to discuss with you what kind of things that you should do in order to study or go into these research areas, let me just explain you what I did, right? Then you probably have an idea. So as Fatima told me, so after the A levels, as all of you, I went into do the physical science degree and got selected for the special degree in physics, the University of Ruhuna, and then followed all these hardcore physics subjects like quantum mechanics and classical mechanics. And I guess you know about these things if you are in the university. And then once I am done with the special degree, then I got a scholarship from University of Houston to follow the PhD in USA. However, it is until that time I never had an interest to be honest, I never had any interest to do any kind of astronomy research. It was once you go outside and see things, then you sometimes get the interest, right? And then since I wanted to do some observational astronomy, I moved to the University of North Dakota, which is a different university. You can do those transfers, and then start doing astronomy research there for my PhD. So I had several research grants there, and so finished my PhD, and then came back to Sri Lanka again in around 2018, and now working as a senior lecturer at the Department of Physics. So that's what I did actually, and you could also follow a similar kind of career path. And let me just add few things to here. Now, so during this time when I was doing my PhD in astrophysics, the advantage is once you have a physical science degree, especially a special degree, or a general degree plus a master's, you can apply for scholarships. And usually, if it is in USA, usually you get the graduate teaching assistantship for most of the PhDs in the science field, and then you may be converted. I mean, if the research grants are available with your professors at who you are working, you may be converted your teaching assistantship to the research assistantship, which means you will be, working full time in your research and you will get paid for that. So that's how it works. So in my case, I was a teaching assistant for a few years initially, and this was pretty much similar to the demonstrator positions that you have in Sri Lanka. And so I had a NASA grant for 1 year for my research that I did. And then I had a fellowship for a few months to finish my PhD. So that's how it worked. And so I'm not going to, explain in detail because of the time limitation. And then once I came back to Sri Lanka, I worked in another grant, one of these head grants where we developed some technologies related to the astronomy. Basically focused on instrumentation astronomy at that time. Now, during my PhD, I was doing extragalactic astronomy. So you can do this, the switch, the field always. There is no, barrier for that. And so basically what we did for the past few years was trying to, establish a meteor camera network for Sri Lanka to observe the meteors. And then we worked with, fabricating telescope mirrors so that you can manufacture telescopes. And then we finished with an interesting project, which we at the end we worked on a convolution neural network processor architecture, which is completely different approach when you consider about astrophysics. It is more into the the computer side. And what you can understand here is you don't have to be purely in physics to do this kind of research, as you can see here, right? So you kind of can move here and there into different fields. I mean, you have to actually, there are no clear and cut different research fields. And so in my case, these are some of the research projects that I worked and I have been working. So my PhD, I was studying about the star formation in galaxy clusters, and this is basically focusing in the field of extragalactic astronomy. Even though you see here the word star formation, that is actually measuring the star formation rates indirectly inside the galaxies, inside galaxy clusters, not looking at individual stars, right? So you have to understand it. So that's why it doesn't belong to stellar astrophysics. It is extragalactic astronomy. And then again, this red sequence of galaxies, that is another project that I worked, which is again about, a topic in extragalactic astronomy. And this third one is still continuing with one of my MPhil degree student, is zero galaxy formation. So that is again related to the extragalactic astronomy, which is my main field of study. And then we did some stellar astronomy research as well relating to the double stars, which means that you have two systems with two stars together. So you probably have heard about that. And then for the instrumentation astronomy side, we started developing these telescopes and all sky camera units. And then when we go into this little bit high-tech side, so we actually start developing a reconfigurable convolution neural network processor. So that's not related to astronomy, as you can see, right? So it's a completely different subject. However, we are going to use it for the as an application for the atmospheric science and also object classification. So what we are trying to test, I mean, the main work in the process architecture is now done. So now we are trying to improve it for classifying objects, especially for these space objects like galaxies and those kind of things. So that's why it relates to astrophysics here, but the core is actually coming from, you know, the computer engineering and computer science. Right. So these are some of the images that I captured during my PhD time. So what I was doing there is, for my study about, you know, the star formation in galaxy clusters, I had to observe galaxy clusters, right? So which means in order to observe the galaxy clusters, usually the galaxy clusters means they are in this scale. So if I go back to this particular image, you can see you have the solar system, our galaxy, and then a local group of galaxies. That's what you say, this one. And then you go into this last image that you have. The galaxy clusters are actually in between the supercluster and this local group, right? So these are entities that you have collections of thousands of galaxies together. So I was looking at those kind of things. Then you have to look at, you know, billions of light years away from us, right? So in order to do that, you need to have a very large telescope, right? So you cannot do it from these smaller telescopes that you usually have, you know, in our in day-to-day lives. You used to have these smaller telescope to look at the planets and all kind of these things. But you cannot observe galaxy clusters from these smaller telescopes, that you need to have these very large telescopes, right? So I basically used this telescope right here. I don't know whether you can see my pointer. So this is one of the largest telescopes available in US observatories. And so what I was doing is, they had a very sensitive camera attached to that. And what you used to do is, you go to the telescope, and inside the telescope, you can sit like this. So this is me taking these images. So you are not keep looking at the galaxy clusters from your eye, right? So what you are doing is so here is in the left-hand side, the top left-hand corner image is what you called as the telescope control panel, that you use your all these controlling units to rotate the telescope and focus it, those kind of things. And you can see that it's a lot of work, right? And then you get all these images to the detectors, and we use CCD cameras mainly for this. And then once you have these images, you get it to the computers and then check the images and then save it, that later you can use for the analysis. So and you use different filters to, you know, do these star formation measurements. So that's what I did. And then the second one is another telescope that I have used at that time. It's a very little bit smaller one than this particular telescope. And we also did some observations for to test the star formation rates. And this particular image that you see in the lower right-hand corner is actually an image of the Orion Nebula. Maybe I think you should be able, if it is really dark, you should be able to see Orion Nebula in these days, as far as I remember. So this is an image that I took from this particular telescope right here. But my focus is not looking at the Orion Nebula, it's actually looking at the galaxy clusters. But just to give you an idea what kind of things that these telescopes are capable of, I just put that picture right here. And so this, I just put this slide just to give you an idea. And this is like doing observational astronomy, actually. So you go for the telescope sites and do the observations, right? And this work is little bit, you know, it is interesting, and at the same time, it is a little bit harder in the sense that you need to stay up the whole night, right? I remember I was there for like 7 to 8 nights, that you start your day evening like 5:30 p.m. or like in the evening, and you have to do the observations until the following morning. So that's what happens usually. And so that's one area, one research area that you can think of. Right. So that's about a little bit about my story. Now, since you need to know that what you should do, basically, in Sri Lanka, what you can do is the main thing is to have a 4-year degree. If you want to, that's the easier way of doing. I mean, enter into this path. Now, currently, as far as I know, maybe I am wrong. There are no degrees specifically devoted to the astrophysics, right? However, you have, I mean, almost all the universities have physics degrees now, and the engineering computer science also works in most of the time. As you can see in the reason I gave you some of these research projects that I am doing, you can see that some of them are not directly physics related. Most of the work is coming from engineering, right? And some of them, most of the work is coming from computer science, but you need to have some kind of small physics knowledge as well. And some of them are, you need to have a very good physics knowledge and some small amount of maybe programming, computer science knowledge, right? So that's how those, most of the time, these projects in the astronomy and astrophysics work, because it's a different field that you need to combine all the other things. Now, one research field actually I forgot to mention there is another field called astrobiology, which means you need some biological knowledge as well to study astronomy. That's kind of a different field. And so, of course, now it's a lot easier if you have a 4-year degree with a good GPA to continue for these fields. Or else you can have a 3-year degree plus a master's, right? Maybe sometimes 1 year of your master's may be enough, right? So those are the basic requirements that you usually should have in general, right? So this could change in specific situations, and there are exceptions as well. And the other thing is the English requirement. So that means you usually have to, have the TOEFL or IELTS in general, and there are exceptions as well, because in certain countries you don't need that. And then specifically for the US universities, sometimes you need this standardized test called GRE. This is called Graduate Record Examination. Maybe some of you know about it. So this is a separate examination that you need to pay, and then have to, get some marks in that examination. This is not compulsory, but I mean, some universities do need it and some, don't care about it. So it's kind of, depend on the situation. And some of now these first three requirements are kind of a must, that you should have a 4-year degree with good GPA. And again, there are exceptions. Sometimes, even you have less GPA, sometimes there are ways that you can, overcome that. Or you have a 3-year degree plus master's. So that is, so you have to have either one of those, right? Having a 4-year degree makes it much easier, but 3 years plus master's also works. And then you should have this English requirement. And then, of course, some research experience and the programming skills, data analysis skills. So they always help. So that's why it is important when you enter into the university, you just follow the degree and at the same time try to engage in some kind of research, right? So this research experience, for example, if you are going to this astronomy field, maybe a little bit of some kind of voluntary research may be helpful, right? So that happens always. And these standardized test requirements, as far as I know, it's only needed for US universities. Now, if you have done some kind of good research, you can, apply for the Europe and Australia countries as well. So they do not usually require you know these GRE results as far as I know. And right, and the next task is once you have these qualifications, you need to start applying for universities. Now, if you are specifically interested about astrophysics, then you need to search for the universities that astrophysics or astronomy postgraduate programs are available, right? So that is something that you need to be careful if you are specifically interested in astronomy and astrophysics, right? Because there are certain physics departments that they do not have astronomy research going on, and there are certain departments that they do not have physics. Certain universities that they do not have physics, but they have separate astronomy departments, right? So just look for those. And so one way of looking at and figuring out the universities is this link right here that I have given you, but this is not the only way of doing it, just one way of doing it. So if you just go through this link, this is the link related to the American Astronomical Society, and it gives you the list of all the universities that you have, you know, all these and the graduate or the postgraduate programs related to the astronomy, right? Now, you may have a question whether you can do something without doing a postgraduate in astronomy. You can, but I mean, it's hard. It's not that much easy to directly go into a job just by doing an astronomy basic degree or something doing an astronomy. I mean, sometimes you may be able to find something in Sri Lanka, but it's also very limited. You know that we have only few institutes in Sri Lanka. So I know that the Arthur C. Clarke Institute has some facilities, and then I guess that's all I know. Maybe you can. I don't know the qualifications that you need. Maybe you can join with this the planetarium, and there is one private institute that is called Institute of Astronomy that I know that who is doing these astronomy courses. But if you need to, you know, go into more professional level, it is always recommended that you go for a higher degree first in astronomy. Right. Now, the next question most of the time when I do this presentation I have is, do you need to have any astronomy, astrophysics background to start your postgraduate? To answer this is yes and no, because having astronomy and astrophysics background is always helpful, but not necessary. For example, the only experience that I had was the two courses that I followed during my special degree related to the astronomy. I mean, not two courses, only one course actually, which taught me astronomy and plus cosmology. And so my advice is for this is, if you are in the university and if you have a plan to do more astronomy or astrophysics or do some kind of postgraduates in astronomy, check whether you have a course at least in basic astronomy or astrophysics in the university. And if there is an option that you can take it, I mean, of course, if you are physics, most of the time you can take it. Sometimes it is optional. Now in our university, there is an optional astronomy course that anybody can take it in the science faculty. So just take that course so that you have the basic knowledge, right? So then you can, you know, build up from that. And also if you have the opportunity to do some kind of research in that relates to the astronomy or astrophysics, just go for that if you have a plan in future to go into this field. That will be always helpful, right? So that is my advice. However, there may be certain degree programs. I know that there may be students from sometimes students from different faculties like engineering, maybe computer science. So they may have a question whether they cannot do astronomy. They usually, can do it as well. So once again, if you have an option to do some kind of astronomy, astrophysics, just do it. Course. Course in astronomy or astrophysics, and then whatever the technical knowledge that you develop from your course, you can later relate that into astronomy. For example, especially for the instrumentation and for the technology side, if you are interested, right? So that's how you can move on in that field. For the physics, it's straightforward. If you have done physics and if you have some 1 or 2 astronomy courses, you can easily apply for these programs. Now, especially for the US universities, they have a kind of a structured program that you will be selecting your research area once you come here. So if you are interested, you can, apply and later decide. And I have one example that one of my students who didn't actually have any courses for her undergraduate study. She is from actually Eastern University. However, she was very interested in astronomy. And I remember she was working in SEDS few years ago. So what she did was, I know that she was engaged with this lot of outreach activities so that she has a very good background knowledge in this area outside the degree. And then what happens was, then she needed to do the astrophysics research. So she joined with me to complete her research by having a special permission, I guess, from her university. And then even though she didn't have any kind of astronomy courses taken, from that knowledge and experience from the research, now she was selected for the Oklahoma State University astronomy program directly. I guess now she is in the second year now. So there are options like that. If anybody needs to, go into this field. Right. So different skills that sometimes you need while having these basic qualifications. As I tell you, undergraduate physics, astronomy knowledge. So it doesn't need to, if it is from a course, that is better, but it doesn't need to be like that. If you have, just go for these outreach activities, observations, and just build up your knowledge yourself. So that will be definitely helpful, right? Even though you have a course, 1 or 2 courses, just go outside and look at the sky and join in with these, stargazing programs, and then you do these outreach activities and working in the societies like this, especially like the SEDS, will be definitely helpful, so that you build up your skills and the experience for the subjects. And sometimes these kind of skills are more important than the knowledge that you are getting from a course, right? And then of course the programming skills will be very important in future for the astrophysics research. The reason is actually you are now getting a lot of data from these large telescopes. You usually, most of the time, you don't have to go for these telescopes and do the observations. You get the petabytes of data from these large telescopes. Now you have the James Webb Telescope operating, a lot of data is coming through that, and a lot of projects are now based on that. And I guess within the next year, or maybe at the end of this year, there is the other big project called LSST, which is again a ground-based 8-meter telescope with the most powerful digital camera now in the world attached to it. Will start its research program. So the lot of data will be, kind of flowing into this astronomy research. But when you go and need to analyze those things, it is not the astronomy. So even though you have some astronomy knowledge, the programming skills are essential, right? Now, from my experience, I know that most of the astronomers and most of the research groups now use either Python or R most of the time. There are other programming languages they do have, but 90% of things now happens using Python. So it is always helpful and essential, I guess, that you should have this programming knowledge if you have a plan to enter into the astronomy and astrophysics field, because of this huge amount of data that you have to, work with. And then statistics knowledge. So yeah, once you tell you should understand now that if there is huge amount of data is coming to, then always you have to have statistics knowledge to analyze, right? So undergraduate courses, or maybe the experience that you have, some astronomy knowledge, which is, even though you do not have the courses, you can easily build up that. And then the programming skills, especially Python and R also will be helpful. R is a language that I think most of the time mathematicians use it. And then the statistics knowledge, right? So those are kind of three cornerstones that you should always have. If you have good skills in these three areas, it is very easy in astronomy, right? Right. It was not like this, let me say 10 years ago, when I was starting my PhD, it was about, going to the telescope and do the observations and then just come and do the general analysis. But now the things have changed very rapidly. So you should always have these skills that you need. Right. Now the next question is, you can do these postgraduates and everything. Then the next question is whether you have jobs in astronomy. I mean, interested and exciting about the subject is one thing. And the next thing is, once you are done with everything, whether you have a job in that field, right? Now, as you see that astrophysics is not industry-related subject, and therefore you do have jobs, but not as common as the other fields. I have to say that. However, you always have postdoctoral positions available, which means usually once you are done with your PhD, you just carry out your research in different research groups and you get paid for that. And those are called postdoctoral positions, which are actually not permanent positions, by the way. It's kind of 2-3 years of doing research. And this is interesting because if you are interested about this field, then this particular job is something interesting for you to do. And then you have to go for the faculty positions, which is what I am currently in, which means you have to join with the university and start teaching astronomy and doing research. So that's something that you can do. And the countries like US, Australia, Europe, then you have national observatories. So they are running these very large telescopes and they need staff to manage those and taking data and those kind of things. So they have institutes for that. So you can work as a research scientist in those. So the NASA is one thing. And then there is another one called Space Telescope Science Institute in USA. So that is another place that you can work as research scientist. So there are those kind of things, and there are research labs. And so those are kind of directly related jobs if you are really interested about astronomy. But the good thing is that in case if you feel that you don't need to be in the same field, and if you need to go into a different job outside the astronomy field, there is an advantage in astronomy because you can easily move into the data science field or to a software company. The reason is that, especially if you are doing a PhD with that involves huge amount of data, you automatically develop your skills in this field. So that's why in the previous slide, I showed you that your programming skills and statistics knowledge is very important. So this is what you will be doing most of the time in nowadays in most of the research areas in astronomy, right? I mean, there are exceptions always, but most of the time, this is what you will be doing. And so if that is the case, you can easily move into a different field. Now, let me show you that some of the statistics, I think this since the time is running out, so this may not be important for you. This is what this shows is in 2020s, the number of PhDs in US universities in that related to the astronomy. The solid, the blue line is actually, as you can see here, number of PhDs awarded in astronomy and astrophysics in these years. You can see that continuously increasing the number of PhDs, and that's obvious for the other fields as well. And then their funding has decreased, so that this dashed line is kind of funding that comes to different institutes for the astronomy, and then it has decreased at a certain point and then has increased again. And this may be important for you, but after these postgraduate studies, what people do, right? Now you can see that in this the graph, most of them are in each and every year. Most of the students after their postgraduates, they used to go into these postdoctoral positions at different different areas in the country and different areas in the world, and then some of them used to join with the faculty positions, which means the similar position that I am in. You join with the university and then work there. And then there are certain small number of people that used to go into other jobs, right? So that means, so they are not permanent sometimes, right? And you can see that the number of positions has, the people working in this field has increased continuously when you get close to the 2018. So that means this area is actually expanding, that you get more opportunities, but at the same time, you have more students in the field as well, right? But when you look at the Sri Lanka itself, it's a different story because you do not have much people working on this field as professional astronomers. It's very less, right? But it's not the case if you go to the whole world. There are people actually working on this field, right? Now, from the statistics, usually the 20% of astronomers leave this profession for the other careers, right? And this actually keep increasing. And the once again, the advantage is actually the skills that you develop in this field as professional astronomers, especially if you are working with the data, you develop a lot of skills that are important for these other jobs available in the market, right? So that is one of the advantages that you have. So that's what I have mentioned here. The many job seekers with graduate level training in astronomy are pursuing the data science careers. That is basically because you know that this topic, data science, is very popular now in Sri Lanka as well, and popular among the world because there are a lot of jobs available. It's a new emerging field that you get higher salaries. And because of that, people used to follow the astronomy and then move into this field, right? They can easily do it because they have a very solid, very good background in statistics and programming when they finish the PhD. I mean, the most of them, right? If they are working with a lot of data, right? So that automatically happens, and so that with a very small, extra knowledge, you can do that transition. So that's why it happens, right? So I have a lot of examples that I know that people have presented about moving into these different, especially into the data science career, which I'm not going to present here because of the time limitation. And having said that, and this is the last graph chart that I want to show you. Actually, this is not directly related to the astronomy. This is actually overall physics postgraduates, what they are doing, right? And you can see that once you have a postgraduate in physics, only 19% of them are working in the physics field, and some of them are physics education, and 15% goes into the engineering, and then the 20% working on the computer hardware, computer software, and 10% in the data science field. Like that, you can see that it divides, right? So what you need to keep in your mind is you do not need to, concentrate it, though, narrow into one single field. You can see that even though you are narrowing down into one single subject, the skills that you develop will be applied to the other areas as well. And so I'm going to finish with that slide just to, so I hope I gave you a kind of a background with this field about the astronomy, what kind of, so what I tried is actually give you a different idea about different areas that you can work on, and then what kind of qualifications that you need to have as university students to move into these different areas, and the skills that you have to develop. And then also the other side about the job market, whether you have jobs by doing astronomy, or what kind of things that you can do, right? So this is the kind of the current situation of this field. So I hope you get an idea about the different fields and different pathways. And let me finish my presentation, and I would like to have any questions.
Thank you so much, sir, for that interactive session. So we have already gathered few questions. So is it okay if I
Yes,
ask you the
please go ahead.
questions?
Yeah.
Okay. So the first question, I am currently following BSc Special in Physics. If my overall GPA lower than 3.0, is there any way to pursue the higher studies in astrophysics? Also, can I get a job in astronomy career with BSc Special? So this is the first question.
Right. It's if I know students who have lesser GPA than 3.0 and still manage to find positions even in USA. It's not as easy as having a good GPA with a physics special degree, but you can still do that. And what some of them has done is, in fact, I know that there is one of my friend from my experience, I know that who has a 3 general degree without a class, and did the physics PhD in USA, now working as a senior data scientist in one of the companies, right? And the way that some of them did it was they started doing a master's degree, and what they have done is, in the master's degree within the first year, they gave their full strength, have very good grades. So then what happens is, once you submit your applications to the PhD, your the committees that who are looking at your application see a very good improvement of you, so that you can explain it. And plus they have very good GRE scores. So that's how you can overcome it. I mean, you can do it, right? And the other thing is, if your research is very, very relevant, what you are, that where you apply. For example, let's say you do a very good research in extragalactic astronomy, let's say about, something about, galaxy evolution or something like that. And you have also published that result as a journal paper or something like that. And then they used to give a huge weight on that. Plus, if you have a very good results in courses in your master's degree, at least for the first year, that will be very helpful. I mean, you can do that. I have seen that people are doing it. It's the problem is actually it's not as straightforward as having a good GPA in a special degree and then applying directly. But you can still do that, because I cannot say that you cannot, because I know my friends who have done it, right? They are in better positions than me as well, earning a lot of money. So So it's doable. Any other questions, Fatima, from your side?
Thank you so much, sir. I
Yeah.
hope the person who asked this question got the answer. So the second question is, as a mechatronic engineering student interested in pursuing higher studies in astrophysics, are there any specific courses, specialized skills, or experiences you recommended that I should follow beforehand?
Is it, can you just read through the question again, please? Sorry.
Yeah, sure, sir. As a mechatronic engineering student interested in pursuing higher studies in astrophysics, are there any specific courses, specialized skills, or experiences you recommend that I should follow beforehand?
Um, I think for me, uh, best way is looking for the instrumentation side since you are doing mechatronics, right? So it's directly related to the instrumentation because there are a lot of uh, there are places that you do this instrumentation astrophysics because the depending on your field, it looks like it is more relevant. Otherwise, what you may have to do is maybe follow a master's degree somewhere related to the astrophysics. And as far as I know, you cannot do it in Sri Lanka, then you have to try it for a different country. I know that there are the students sometimes used to go to France and sometimes Italy for these masters. And once they finish the masters, they can easily find PhDs in that field. But if you are interested in more into the instrumentation side, that will be more beneficial. Now, in terms of the courses that you are asking, I don't, let's see, the problem is if you have an idea or expectation that you will be following astrophysics in future, any kind of introductory course that you have in your university, I don't know which university are you from, and if you have a chance to take it, take it. Right? That will be the best thing. So that will definitely helpful. It will be definitely helpful. For example, even if you go for the instrumentation physics, the advantage of having some background astronomy knowledge is always helpful. I mean, you can always, I mean, learn it yourself later as well. But if you have the option to take a course, then take it, right? I mean, it's not a hard and fast rule, but you can always if you have the chance, I would take it and then look for, especially if you are interested, you can, I mean, I hope that you will, if you are doing mechatronics, you should be interested in the instrumentation, automation, and these kind of stuff, right? And that's what most of the students do because I have one student who interested in astronomy and astrophysics, but he has done a lot of computer science and engineering things. So what he was the one actually who basically worked on this reconfigurable convolution neural network processor architecture because he was kind of a computer guy. So then you relate it to astronomy, but you still work in your field. So that's how it works. So I guess that will be helpful for you.
Thank you, sir. So the next question, I'm doing an undergraduate degree at SLIT in software engineering. So will I be able to still get a career in astronomy field?
Mhm. I think once again it's the same. I have to give the same answer because I mean, if you are doing software engineering, I mean that's basically go into the if it is software engineering means you should have the computer science knowledge, right? And those kind of knowledges can be easily convertible to the astrophysics degrees. And let me you can get a good idea from let me just share you a uh, something here which will be helpful to everyone. Let's look at. So I am sharing this. website, and let me see whether I can share that here as well. I just posted the link for everyone, and let me. So this is just one example, right? There are a number of websites like this, and this is the American Astronomical Society job register, which used to post all the jobs all over the world here. And there are different jobs. And the first thing is you can see that the faculty positions, that means the university lecturing and assistant professor, those kind of levels. And there are two sections called, permanent and non-permanent positions. And then if you go down, you have postdoctoral positions. I think you can go and look at what kind of things that you have. You can see that there are large number of jobs here, right? Postdoctoral positions. But to be honest, there are a large number of applicants as well. And if you go down a little bit, all of these are, let me see. So these are actually these PhD positions. This is called pre-doctoral, the things that you can do after your degree. And if you go through in this particular section, you will see that there are some of these positions. For example, here is something called PhD position in computational galaxy formation. Now for this one, sometimes it may be, I don't know what they're asking. Sometimes they may be asking more computer knowledge, sometimes important than the astronomy knowledge. Of course, it is always helpful to have some astronomy knowledge, but sometimes the computational knowledge is important, right? So you cannot do that without the computational knowledge, right? So because it says the computational galaxy formation, so they used to so they have applicants with interest, galaxy formation, computer simulations, and extragalactic astrophysics in general encouraged to apply. So if you will sometimes see that they kind of motivate students who having good computer science knowledge to apply for these things, right? Now, one thing you can do is there are some courses that you can take in astronomy to develop your knowledge. If you do not have any kind of, I guess it may not have astronomy courses. So you can do those kind of courses and develop your astronomy knowledge in background and then apply for these kind of positions, right? Sometimes they consider it. And I can't see it here, but I have seen sometimes the few positions they are asking for software engineers actually, right? Now, for example, right here, you can see the Associate Science Software Engineer for the Space Telescope Science Institute. This is the one that I just mentioned few minutes ago. Space Telescope Science Institute, that is an astronomy institute, but they are asking for Associate Science Software Engineer Grade 2, right? And that's how it works, right? You can see that. And here is the same institute, the Space Telescope Science Institute, Staff Astronomical Data Scientist, Grade 2. And so you are primarily working on in astronomy, but what you need is you should be a software engineer, right? So that's how it works. You can see that there are ways of doing this, right? I guess this is an example, so you probably have the answer there, right? Just go and look at these sites and you will see what are the qualifications that they are asking. And as I always used to tell, try to get a background knowledge in astronomy if you cannot follow a course. That will also be helpful for these kind of positions. But what is more important is the field that you are working, right? I hope that answers your question.
Thank you, sir. So the next question, as a third year undergraduate majoring in physics, how can I get prepared for the GRE in physics from now onwards?
To be honest, I haven't done GRE physics. But GRE physics is mostly, I have seen these exam papers. It's mostly consists of I currently don't have an idea that which university are from. Anyway, that what they are asking is the knowledge that you acquire from these physics courses most of the time. So they have quantum mechanics, classical mechanics, then I guess the nuclear physics and those kind of subjects that you used to learn in your 4-year physics special degree, starting from the first year, all the physics courses. And then you have to practice it from the past papers and all these things. I think that's it. So that's the only way of doing it, I guess. One thing you maybe, I mean, just double check whether the GRE physics is still acceptable in most of the universities. I don't know. Most universities now, I think, they don't even ask for GRE physics. I mean, if they are not asking, you don't have to do it. Some of may be asking about it, but very recently I haven't seen that most of them are doing it. So, I mean, that's it. I mean, in terms of the content, it will be mostly the same content that you are having in these classical physics special degrees in Sri Lanka. The thing is, I may be wrong because I haven't checked these question papers very recently. They used to have like 100 questions, like 10 years ago. I don't know whether it's the same thing now. And those are MCQ questions. And you have to be, I mean, you may have the knowledge, but read the question and answer to these MCQ questions within that given time frame. You have to have a good practice and very good knowledge in physics, right? About very basic concepts and everything like statistical mechanics, quantum mechanics. So you just need to master those subjects in order to, write this exam. But once again, just double check whether you need it still, right? Most of the time, most of the universities, I guess, maybe not asking about it now. Just check it. I'm not sure about that. Any other questions?
Thank you, sir.
Yeah.
So the next question, how do the current global economic crisis and ongoing conflicts between countries impact international higher education scholarships?
Now I am actually residing currently in US, Dallas, Texas. I don't see there is any impact, especially for the PhD opportunities in these countries, right? I mean, there is no any, I can see that all of these news are in everywhere, but in terms of the PhD positions and all these things, I I may be wrong, but I, in my personal experience, I haven't seen any big impact up to now, right? Maybe this may be change in future, but for now, I think you don't need to worry too much about it, right? The COVID and everything, even in during those times, there were students who came here for the PhDs, and still it's the same trend and same process. A lot of students come here for the PhDs, and I don't see any, changes due to those kind of crises still happening in these countries. And to be honest, I have a very little knowledge about, the Europe and Australian countries, but I think it will be the same, right? Because the voice in somewhere else, no? The most of the time students to go to these postgraduate studies to the Europe countries like Italy, France, and then maybe Japan and to the Australia. And some of them used to go to the China. And then for the science, most of the students used to come to USA. And I don't see there is any impact for those students until now. I guess that's answer your question. I mean, you don't need to worry basically about it, just do your studies.
Thank you, sir. So the next question, what is your opinion regarding the implementation of astronomy and astrophysics related jobs in Sri Lanka? And is it possible to gain knowledge abroad and implement that in Sri Lanka?
Unfortunately, I don't think that with the current economic situation in Sri Lanka, you can have a job in that directly related in astronomy and astrophysics in Sri Lanka. There are only few positions that you can go unless you join with the university and the physics department. You can do that. Other than that, outside you have the Arthur C. Clarke Institute. If you need to join, there are very few positions, and I actually do not even recommend of looking at jobs that are directly related in astrophysics in Sri Lanka in these days, especially. But however, you can do something like this. You can, as I have shown in my presentation, if you are very interested in doing astronomy, you can actually do your postgraduates in another country and carefully select a specific research field that you work with a lot of programming and data and statistics, and then convert your career into a field of like data science or something like that that more jobs are available, right? I think that's what you can do at this point, because there may be exceptions, because there are only few places that you can work inside Sri Lanka if you do an astronomy degree. I have to tell that even I did astrophysics degree because my ultimate aim is to work in these faculty positions. So if you plan to join with the university with good research background and a lot of publications, that's okay. You can do that. Other than that, if you are thinking about, go into an astronomy and astrophysics related job in Sri Lanka other than inside the university and maybe the Arthur C. Clarke Institute, I don't see any kind of recent improvement. So, in nearby future, there will not be a lot of, opportunities. And of course, the reason is that astronomy research is not directly related to industrial applications, so that doesn't contribute to it doesn't directly contribute to the economic developments basically, but you can find ways of doing it. But I don't think this is the time for it, and this is my personal idea, by the way, that may be wrong. But you really need to be in the astronomy field and doing a job related to the astrophysics. I would recommend mostly you will be successful outside the country most of the time. So once you success outside, you can think of come inside and do some work. Other than joining a university or maybe work in the Arthur C. Clarke Institute or something like that. So that is very limited. Yeah. Any
Thank you
other
so much,
question?
sir.
Yeah.
So the next question from the last question from our side, sir.
Mhm.
I am a third year student following BSc special degree in computer science. I have studied physics in my first 2 years and had 3.5 GPA for physics. How can I establish a career path in astrophysics?
I think it is still the same answer that I have to go, because now you have selected your special degree different. Not different area in computer science. No, it's now you have to finish it first, and then you probably have seen the job register that I have shown you. You can still join with these postgraduates in astronomy and astrophysics in a way that you need to specifically find the places that are looking for these, computer science knowledge. or else what you can do is, since you are in now following the computer science special degree, you can just go through even the postgraduates with that. And then you can think of, switching the field into this astronomical field. Since you have a 2 years of physics background as well, you can, especially if you start doing a postgraduate, especially a PhD in a different country, let's say USA, most of the time you have the option to, get some courses outside your field. So that usually happens. I have done that as well. Then you can, select maybe some astronomy courses from that university, because most of the universities in USA, you kind of at least one or two astronomy courses are available. So you do that, and then you complete the PhD in the same field that you have continued, let's say software engineering or computer science, and then you can think of, uh, applying for a career in, these areas where you use your specific knowledge in computer science in that field. That field means astronomy. So those are the jobs that they have posted in the job register, like software engineers that they need for the Space Science Telescope Institute, which means you primarily work in that field. However, your specialized area is still computer science. I guess that will be more safer, because uh, then you kind of open up a lot of options. You have the astronomy if you need, but in case if you can't find it, you will still have the computer science knowledge, which is more demanding, I guess.
Thank you so much, sir. So we are getting lots of questions in the chat box, but the time is lacking. So we have to wind up the session. If there's any more questions, you're free enough to contact us at any point. We'll try our maximum to help you out.
Yes, what you can
And
do is,
here you have it.
if you have any questions, and in case, if you feel that there are a lot of questions that students need to know, you can just have a Q&A session separate and just ask for a time. I would be, I will do that. It's not a big issue. Yeah. But then
Thank
now
you
the
so
time
much,
is close
sir.
to midnight for me. It's almost past the midnight.
That's what, sir. You have put lots of efforts and many things. Thank you so much, sir. Even though nighttime there, you still took your own time and helped with us. Thank you so much, sir, for that. And we are really grateful for that, sir.
Right. Thank you for having me.
And there you have it, a captivating journey though through the world of astrophysics and space exploration. We have learned about the incredible work of SEDS Sri Lanka, SEDS Japura, the project, and amazing guest lecture. So before we conclude, I want to express our deepest gratitude to Dr. K.V.S. Prasadh for sharing the expertise with us. Your insights have been truly inspiring, so thank you so much. We'd also like to extend appreciation to SES Shapura chapter for their dedication and hard work in organizing this event. As we wrap up this webinar, remember that the journey into the cosmos is ongoing. The future holds limitless possibilities, and we hope to continue exploring, learning, and pushing the boundaries of our knowledge. Thank you all for your participation today, and it's been a pleasure to have you all with us today. Until next time, keep going and keep looking up, and may your curiosity lead you to new frontiers in astrophysics. Thank you.
Thank you.